So, good morning ladies and gentlemen. Today we are starting lecture 10, that is on transmission line parameters. Before we go ahead and do transmission line parameters, we have to do a small talk on computers. Now, what is the history of computers in power systems? There were AC and DC calculating boards. Don't think that computer is a recent sort of invention. Even in 1930s, they were computing, because man has to compute right from the day one. And AC and DC calculating boards were used, and then they were replaced by slide rule. I don't know how many of you are aware of slide rule. When we did our undergraduate BTech, we used to use slide rule for doing engineering calculations. I still have a slide rule with me. If someone wants to have a go at it, have the darshan of it, you are most welcome. Then came analog computers. This is an American spelling, but in English spelling is L-O-U-G-E. They are 1940. Then came digital computer, 1950. I told you about the baby computer, 1948, Manchester. You missed. The three scientists who invented that, they are still alive, and there was a golden jubilee celebration in 1998, in which I also participated. I happened to be there. And the first power system study which was carried out using digital computer was load flow study. And I am sure all of you know load flow. You must have studied in your undergraduate. We will be doing it next semester. The paper was by Ward and Hele. These were the two persons who used digital computer to solve load flow problem. You know what is load flow problem? P, Q, delta, V, solution of these four parameters. The computers gave what? Of course, microprocessors were also used. Computers gave you flexibility, accuracy, speed, economy. The slide rule we used to take a lot of time. Our problems used to be a bit easier in exam because of slide rule, because we used to take a lot of time and they were approximate. If your eyesight is not good, you are likely to get mistake, because you have to use those cursors and things like that. Then came the mainframe computer, mini computer, microcomputer, personal computer. Of course, now you have laptop, you have the palm top, and so on. Offline and online applications. Any problem can be solved offline, and the same problem can be solved online. The news you hear in the various channels, they are real time. Online, it is not recorded. Offline is something which is already done earlier, and now it is being beamed. So, there is less likelihood of any mistake. Now, what is going on is online. I mean, there is no correction, there is no retake, or there is no sort of again doing it. There is a slight difference between real time and online. That's since you know computers so well, you should be able to appreciate. In some, data also comes in real time. R&D, most of the R&D needs computers. Performance evaluation also needs computer. Nowadays, all your GATE papers, JEE papers get evaluated, at least objective type, by machine. There is no human beings required. Data logging, monitoring and control is also done by computer, whether it is a DST, whether it is a railways, whether it is a power system, whether it is a medical system. You go for any patient in AIIMS, all his data will be recorded in the computer. So, data logging, then monitoring and control, everything is done by computers. hierarchical control problems, one after another. As I told you in my earlier lectures, first you have to do forecasting, then you have to do maintenance, then unit commitment, then load dispatch. Of course, sometimes you do state estimation, security, reliability, optimization, and so on, one after another. What are these problems which you solve in a hierarchical way, multi-level way? This is the table which tells you the time scale, and it also tells you the control problem. Milliseconds, relaying and system voltage control and excitation control, they do not give much time. You have to identify fault in no time. That is why when you are studied circuit breakers in your undergraduate, you know now they are fast operating, fast clearing fault, maybe 2 cycles, half cycle, they have gone up to half cycle. It can't be magic within no time, some minimum time has to be given. Then 2 seconds to 5 minutes is AGC, you must have studied AGC in your undergraduate, automatic generation control. Every 2 seconds to 5 minutes you have to run this program of AGC, so that the frequency remains around 50 hertz and plus minus 0.5 hertz is the tolerance given to you. 10 minutes to few hours is ED, economic dispatch. Similarly, for same time you have to do security analysis. Few hours and 1 week is unit commitment. We will be studying all these things in detail next semester under power system planning, that course 860 ESL. 1 month to 6 months is maintenance scheduling. You do not have to maintain in a short term. You do not give your car every day to garage. It will be once in a year or once in 6 months. Similarly, powerhouses are maintained in this frequency. And planning is always done up to 10 years, 1 to 10 years. There is no point in planning for 2050. God knows what system will be there, who will be there, and what will come. It is very, very difficult. Who could have thought in by 1990 that there will be mobile revolution in India? Planning also means modification and extension in the present power system. What are the problems that are being faced currently in power industry and its choices? How we can, because everybody says you have to add 100,000 megawatt in 10 years. It is not a joke. Do we have a manpower development program corresponding? Do we have a corresponding coal development program? So, it is going to be a vast planning exercise, and a lot of people had to chip in and help in developing 100,000 megawatt, and money, of course, that is very important, 4 crores per megawatt. 3600 utilization as against 5100 hours in Japan. It is very pathetic story. Of course, demand is always more than supply, barring few hours and few states like Uttarakhand where you have a surplus power. Now, IIT Roorkee has no power cut. When it was in UP, there was always power cut. So, that is one advantage of Roorkee going into Uttarakhand, that there is no power cut in IIT Roorkee. We are able to use our power plants for 3600 hours as against 5100 hours. It is not restricted to power plant alone. Look at the way the government offices work. 102 days goes in Saturday, Sundays. Then there are 20 national holidays, restricted holidays, 8 casual leave, 15 special casual leave, there is earned leave, then there is a medical leave. So, hardly a government servant works for less than half year, less than 6 months. So, why power system should be an exception? They also work less than 50%. You 8760 hours, you make it half, it is not 3600 hours. So, it is very pathetic. You have spent so much, 4 crores per megawatt, and you are going to use only 3600 hours. It is very bad, as against Japan where 5100 hours. Singrauli, Farakka, Neyveli, Chandrapur, Ramagundam, Korba, these are all superthermal power stations. Superthermal is any thermal station having more than 2000 megawatt. The captive power plants are on increase, that is a private generation. now 20%. It used to be 7% before reforms era, now it is 20%, and it is likely to go up. More and more privatization. Now we come to the chapter 2 of the book, that is the transmission line parameters. Of course, you must have done it, so we will only review it. We are not going to go into detail, since all of you are BTech or B electrical. I am sure you know these 4 parameters: inductance, capacitance, resistance and conductance. In this particular lecture today, we will talk on inductance and resistance, which are series parameters, right? They are always in series. And capacitance and inductance, they are shunt parameters. They affect the performance of a transmission line. If you change their values, the performance of transmission line will change, and hence it is important, it is imperative to evaluate these 4 parameters of a given transmission line, or while designing transmission line, we should find out what should be the ideal values of R, L, C, G. I just now told you before few seconds, R and L are series parameters, G and C are shunt parameters. What is G? We almost always neglect this G while doing any power system computation, any power system calculation. It is there due to leakage over line insulators. We must know at least why it is there, and its unit is mho, Siemens, the opposite of ohm. R and L are uniformly distributed along the line, UDL. Z series, the figure I had drawn in last slide, is R plus j omega L, and j omega L is called x. This omega L is nothing but x. X is equal to omega L, and omega is nothing but 2 pi f L. F is frequency, which is 50 hertz in some countries and 60 hertz in some countries. Since we were inheriting UK system or English system, our frequency is 50 hertz. The American system frequency is 60 hertz. The French system, it is 60 hertz. Out of these 4, L is the most dominant line parameter. Like UP is the biggest state in India, so L is the most dominant line parameter. You cannot ignore L for anything. Inductance has got to be computed, and you know this law very well. E is equal to L di by dt, the voltage across inductance. That is, if there is inductance and this voltage E, this is L, this is I, this is related by this. This V is unit, volts. So, do not confuse that it is a parameter. L di by dt. L is given by d psi or d lambda by di, Henry. What is psi? Psi is a flux linkage. Some people write it lambda also. Weber turns. This is your physics. You must have done all these things in physics, of course in electrical engineering. For AC, when you talk of alternating current, lambda is equal to Li. What is mutual inductance? There are 2 coils, close, current is flowing So, that current flowing in one coil also affects the neighboring coil, and this mutual inductance is also given in Henry's, which was the unit of inductance to honor a scientist Henry. M12 is equal to lambda 12 upon I2. Okay. Required while considering coupling between parallel lines and influence of power lines on telephone. Where do you use it in practice? All of you must be knowing that we do not have a single line transmission, we have double circuit transmission. Why? That helps you in transmitting more power plus reliability. It is very unfortunate if you are, then only both the lines will have fault simultaneously. Both kidneys will fail very rarely. It is normally one kidney and people can leave on another, right. So, similarly one line will only fail at a time, so that you can continue to transmit some power, minimum amount of power on remaining line. So, but then there is a mutual inductance, because current is flowing in both. Similarly, you must have seen while traveling in train or otherwise also, the same poles are used for telephone lines to save money. Now, when you have a parallel going the power line as well as telephone line, naturally they have interference. So, that mutual inductance, and we had to have minimum interference. You see, in olden days when you do your STD or whatever, there used to be a lot of noise. Now that is gone. Now you are talking to New York as if he is sitting upstairs, so clear. If you assume that there is a uniform current density, then the expression for inductance is 4 into 10 to the power minus 7 natural log d by r dash. Why there is a r dash? R is a radius of a conductor. The dash means this r multiplied by e raised to power minus 0.25, which is 0.7788 times r. In order to consider internal conductance, we as if we consider as if the conductor radius is modified to a smaller value, 0.7788 times. Single phase 2R line is shown here in this figure. The two conductors are separated by distance capital D. Conductor 1 is carrying current I1, conductor 2 is carrying current I2, radius is R1 and radius is R2. What are the different conductor types? Hollow conductor, solid conductor, stranded conductor. Stranded means ACSR, aluminum conductor, steel reinforced. Why do you strand them? So that there is a good grip and mechanically they are stronger. What happens? There is a central strand of steel and aluminum strands are done alternately spiraled across it. How many strands will be there? It depends on number of layers. The formula is given here, 3x square minus 3x plus 1. If there is only one layer, then it will come out to be 1. If x is 1, then this 3 will cancel out, you will get 1. But if there are 2 layers, then you will see, just check, will you get 7? You get 7, and let so on, depending on what power you want to transmit. So, electrically they are in parallel with alternate layers, spiraled in opposite direction to prevent unwinding. They are spiraled in not in the same direction, but in opposite direction, so that they do not come out, no unwinding. You can see the figure in the next slide of this ACSR conductor. I think this has just been done reverse. this is steel and these are aluminum. This has been prepared by somebody who is not electrical engineer, okay, but you are electrical engineers. So, you will understand this AC aluminum conductor, steel reinforced. Steel is only one central strand, this black one, and not so black is shaded ones are aluminum, 6 are aluminum. Why do you use aluminum? There was a time when you used to use copper. Yes, it is lighter, it is cheaper than copper, of course, less conductivity, it is okay, you do not worry, less tensile strength. I told you plus and minus, whatever you do in life, there is always plus and minus. So, there are 2 minus points, 2 plus points. Overall availability is better for aluminum in India. You do not have to raise your import bill, and hence aluminum is preferred. We keep paper in between layers in expanded ACSR, so diameter increases. What happens if diameter increases? Right. So, it reduces the chances of corona. Corona you must have studied in your undergraduate. It is a forming of a violet color glow around the conductor, especially in a bad weather conditions, when it is raining, when it is snowing, all these conditions, it becomes very easy corona to form. Yes, also. Of course, there is a hissing noise also is heard while corona is taking place. Inductance of composite conductor lines. This is a formula you will have to use again and again. So, you should CTM. What is CTM? Commit to memory, because you will be using this formula again and again in transmission line computation. 0.461 log to the base 10 dm by dsa. Dm is mutual GMD, geometric mean distance, ds is the self GMD, and the units are millihenry per kilometer. If you want Henry, you can always multiply by 10 to the minus 3 and make it Henry, if you are so particular about Henry. Inductance of 3 phase lines. Look, in this diagram, the spacing is not symmetrical, it is unsymmetrical, and that is why D12 is not equal to D23 is not equal to D31. It is a most general case. The 3 conductors shown are A, B, C. Order is immaterial. You can always change A by B, B by C, C by A. In fact, in transposition, this is what is done. When you learn transposition, you might have already learnt. So, there is no need to stress much about it. So, for this 3 phase line, they can be in horizontal also. They need not be in a triangular form. If there is no neutral wire, then the summation of all 3 currents are 0. To avoid unbalancing, transposition is carried out. So, why transposition is carried out? If you are asked in an interview or somewhere, this is what you have to reply. Just to show you one transposition cycle, this is a complete transposition cycle. A, conductor A, after some time it comes in middle, then it comes below. So, unbalancing gets averaged out. Of course, computation you take averaging, so they become bit more complex. You must have seen the formulas, otherwise you can please refer to chapter 2 of the book. any book, blue book, red book, or the black book which is coming, all three, chapter 2 is same, there is no change. Even in the third edition there is no change. Now, the inductance of phase A is 2 into 10 to the power minus 7 natural logarithm d equivalent over R A dash, or in a general way it will be d equivalent upon ds self GMD. ds is more general term because it may be a bundle conductor which is going to come now next. Then ds won't be just R, it will be under root of, you know those things. D equivalent in this case is a cube root of d12, d23, d31, and this is called equivalent equilateral spacing. And if all resistances are same, sorry, all radiuses are same, or radii I should say, are same, then all inductances are same. For equilateral spacing, D equivalent get reduced to D, because then they are equilateral. All are D. So, no D12, no D23, no D31. In that case, D equivalent becomes the cube root of D cube is D itself. The bundle conductor. I have seen many students getting confused between ACSR and bundle conductor. When I ask them bundle conductor, they draw the diagram of ACSR conductor and they get 0 straight away, because you are talking something else which is not asked. So, bundle conductor is an entirely different concept than ACSR conductor. It is economical to transmit large chunks of power over long distances by EHV line. This we are telling you from very beginning. That is why there is a need of transformer, because generation is always at a lower voltage up to 25 kV. You can't go beyond. Why? There are cooling problems, there are insulation problems, safety problems, but the transmission is always cheaper, convenient, economical on EHV or UHV lines. So, you need to have a transformer. But line voltage gets limited by corona. You just can't go for a million volt. There are problems. There are insulator problems. There is a corona problem. There are safety problems. There are interference problems, and so on. So, there is a limit. The limit the world has gone is 1000 kV or 1100 kV, not beyond that. Of course, now there is no question of raising any more power requirement of US. It is already maximum. I mean, you do every damn thing by electric power. What else you need for electric power? Right from the time you get up to time to sleep, all your activities consume electricity. What more electricity you can consume? And the population, they are not going to increase. They are now limiting immigration. They are now not allowing anybody to enter, and they don't have marriage institutions. There are problems. So, there are no children. So, there is no question of power demand going up in those countries. Corona is a result of ionization of the atmosphere when a certain field intensity, that is 3000 kV per meter at NTP, is reached. I don't know what is searched. Corona discharge also creates communication interference, and there is a loss. Don't think I squared R loss is the only loss in transmission line. And there is a Peake's formula, if you recall that term, which is used for calculation of corona loss. You can always revise your undergraduate notes if you have any, or book. And this is very severe in bad weather conditions, as I told you. Critical line voltage increased by using bundle conductors. So, it helps you in avoiding corona. Now, this is what is 3 types of bundle conductor. The from my side leftmost figure shows you only 2 subconductors forming a bundle. The middle figure shows 3 subconductors in a equilateral triangular position, and the third figure from my side rightmost, that is being formed by using 4 subconductors, quadrilateral. More the merrier, but money, aluminum, right. So, it depends what is your requirement. The ds goes up with bundle conductor, ds is self GMD. ds goes up, inductance comes down. If inductance comes down, power goes up. That is what we want. We sometimes have generation, but we are unable to transmit it because transmission lines are not available. So, in order to develop the whole power system, we have to develop not only generation sector, we have to simultaneously keeping pace with generation, also develop transmission sector. Otherwise, if there is no means of power supply available for transmission, that power generation has no meaning. Let us talk of resistance. We have talked enough upon inductance, because inductance happens to be the most dominant parameter. That is what we said in the beginning of the lecture. Resistance, you must have studied in physics. It is nearly 0 in most of the power system studies. We do not consider resistance at all, we ignore it. However, the fact is resistance is very much there. If it is not there, there will be no I squared or losses, it will be 0. So, line power loss is very much there, whether you like it or not, and our aim should be to reduce it as much as possible. This is the 6th class expression for resistance, rho L upon A. This is unfortunately the L and 1 gets similar when you type it. L is length, rho is resistivity, A is area. The total units are ohms. If there is a temperature change, which is always there all the time, if you see any news channel now, they show you live temperatures all the time. It is no more only 9 o'clock news temperature, minimum maximum, anytime you can see temperature. So, with more temperature, resistance increases. Alpha 0 is nothing but temperature coefficient of conductor at 0 degree centigrade, and you can find out the ratio of the 2 temperatures at 2 different T1s, T1 and T2, 25 degree centigrade, 30 degree centigrade. This is some numericals are also being asked in undergraduate, giving you all this data and substitute it and get the values. Of course, we won't ask you those numericals now, you are postgraduate. Very important effect of resistance is skin effect. Uniform current distribution is only possible in case of direct current DC. In AC, I am sorry, unfortunately or fortunately, it is non-uniform. It increases from center to the as you go towards the surface, and it also increases with frequency. So, delta mean is at the center and delta max is at the surface. Delta is normally the current density, amperes per meter squared. This phenomenon is called skin effect, and because of this AC resistance is always more than DC resistance. So, whenever you have measured the resistance of anything in laboratory using your simple circuit of battery, ammeter, voltmeter and potentiometer for changing the values of current, for taking few readings, otherwise your teacher will get annoyed if you take only one reading. So, all these values must have been multiplied by 1.6, a factor which will convert RDC to RAC. So, RAC is equal to 1.6 times RDC. Non-uniformity of current distribution is also caused by proximity effect. Do not think there is only one skin effect, it has a cousin, poor cousin, and that cousin is called proximity effect. There is increase in resistance, though is negligible for normal spacing of overhead line, but for cables where it is very close, the effect is more pronounced, and you are not supposed to ignore proximity effect when you consider cables. You must have studied cables in your undergraduate. There is one very good book on cables by Weedy, W-E-E-D-Y, John Wiley, UK. Both skin effect as well as proximity effect depend upon or proportional to the big alpha. It is not alpha, it is a sign of proportionality. This may be asked in interviews, this can be asked in objective type questions, gate exams. Depends on 4 parameters: conductor size, frequency, diameter, permeability of conductor material. So, what we have done in this lecture, we have covered so far inductance and resistance of transmission lines, why we have to consider them, which is more important, why we ignore resistance most of the time, why we have to consider inductance all the time, various conductor types. There have been tables given in many books from where you can directly read inductance and resistance for a given configuration and given type of conductor. The practicing engineers do not have time to calculate the values of inductance and resistance. In fact, there is a T&D reference book, I do not know whether you have seen that, such a big Westinghouse, and that is still a very good book. It published in 1950, 50 years back, more than 50 years back. Then inductance of composite conductor lines, single conductor, single phase, 3 phase, symmetrical spacing, unsymmetrical spacing, unbundled conductors, bundled conductors, all these things you have of course read it, we have just revised it. Why bundled conductors are used, how they help you, how they bring down the value of capacitance, and since they bring down the value of capacitance, they bring up the value of power transmitted, because the bring down inductance, so power transmission goes up because X is in the P is equal to EV by X sin delta, and if X goes down, P goes up. We have talked of resistance as well, though we neglected still why there is a resistance, what is the formula for resistance, how it varies with the temperature, and what are the skin effect and proximity effect. Now, next lecture we will be doing capacitors, capacitance rather, and conductance we do not have to worry. we will just ignore. In fact, capacitance is nothing but a repeat of whatever is inductance. Formulas are slightly different. What makes capacitance different than inductance is consideration of effect of ground. Why we ignore the effect of ground in inductance? Because there is no sort of a method of images, etc., and it is not a shunt parameter. Since capacitance is a shunt parameter, it has a connection with the ground. Inductance has no connection with the ground. And what happens, how we consider the effect of ground, etc., how we will see in the next lecture, and plus we will talk on fundamental things, that is power, complex power, what is apparent power, what is the real power or active power or reactive power, how do we change the power factor, what is excitation control, how excitation make change of leading power to lagging power to unity power factor without affecting the real power transfer. The real power remains same, V I cosine phi. The correspondingly V I and phi will change, but the total, the product remains still the same, because real power is dictated by load, not by excitation. Excitation is controlling only the power factor or voltage. All these things we will be seeing next time. Any questions today? Yeah.
So in the bundle conductors we can use bundles of ACSR?
Yes, each subconductor can be ACSR, surely, but that bundle conductor is not called ACSR.
So what is the difference between composite conductor and bundle conductor?
Well, composite conductor is entirely different concept. That is, there is a phase A and phase B. Phase A may have n conductors. Now, each one of them may be a bundle conductor. See, it is like this. That you see the book m conductors and there is a n conductor, and then you have calculated Lm and Ln, that particular article. You can see that. So that's I thought since you already done it, so I have not done the whole chapter. We have finished the whole chapter in one lecture, in fact, just to revisit that, just to recapitulate that, whatever you have done maybe a year back or so, or maybe 2 years back.